All right, so how's geometry going?
Pretty good.
Yeah. Are you on chapter 2? Are you on proofs?
Yeah.
Okay. Um, for some reason, I've always found it difficult to tutor this chapter. I don't particularly like the fact that they put this chapter so early in geometry because it's kind of almost the most difficult chapter in the book. Um, So I've always been a little puzzled as to why they start out geometry with proofs. It just seems like it's teaching you to ski by starting you on the expert slope instead of the beginner slope. Do you have any specific problems you can give me?
Mm,
Do you have any homework? Or I've got your book. At least I've got the geometry book by Larson, Boswell, Stiff.
our book is the older book.
Well, mine's pretty old. Mine's 6 or 7 years old.
Yeah, it's probably that one.
So yours at the top says McDougall-Lytell Geometry.
I'll go get it. 1 second. Um,
No matter what the subject matter, Allie, I would like you to bring the problems to the session.
okay.
And that way, because I never know exactly what you're going over in class, I have lots of geometry students and, they go over different material at different times of the year. So I want to keep you current with what you're going through in class. And the best way to do that is if you send me or can give me, even if you can just verbalize the problems, you can give them to me, I'll write them out and we'll both look at them. Typically with geometry, because there's shapes and figures involved, a lot of times it's hard to verbalize. So most of my geometry students usually send me a picture of their material that they have to work on.
Okay.
And if you have some of that, that's probably the best way to do it. In other words, if you have some homework that you need to do,
I'll send you a picture of my homework.
okay. Do you have my email address still? Yeah, I
Mm-hmm.
think you sent me something. Just type those 3 and it's David Cowan 1949. Let me know when you've sent it.
Okay.
This incidentally, like I said, is probably the hardest chapter in the book, chapter 2. So don't get too demoralized. This is not what geometry is about, chapter 2.
Okay.
It really,
I just get confused on the theorems sometimes.
yeah,
Like different theorems.
exactly. And I understand exactly what you mean. And you know what? Don't worry about memorizing. It's not important that you know the name of the theorem at all or the number of the theorem. There is no standard number on theorems. What's important is that you understand what the theorem says.
Okay.
In other words, let's see, you can see my screen, right?
Mm-hmm.
Yeah. In other words, the theorem says that if you have a straight line and you have another line that intersects with that, then angle 1 and angle 2 have to be what?
Linear.
They're a linear
Congruent.
pair, which means they add to 180. They are called supplementary.
Yeah.
And that's a theorem. Another theorem would be if you have two lines that intersect, angle 1 is equal to angle 2 because they're vertical angles, and angle 3 is equal to angle 4 always because they're vertical angles, no matter what they are. I think I got your email. Let me pull it up. I did. Hold on. I'm going to have to download that, I think, to rotate it. All right. So let's talk about two-column proofs. That's about as hard as it gets in geometry. Now, unfortunately, they don't do it on here, but I think the best way to teach two-column proofs is if you have, like, number 1 has the statement and no reason, and number 2 maybe has no statement but the reason. And then number 3 would be have the statement and no reason, and in other words, alternate these. So you're not always having to fill in the reason. But we can do this. So 1 and 2 are complementary. What's the reason for it?
That's the given.
Correct. Angle 1 plus angle 2 is equal to 90 degrees.
Definition of congruent angles.
Definition of complementary.
Oh,
okay. Two angles that are complementary add to 90 degrees. Two angles that are supplementary add to 180 degrees.
Yeah.
So number 2 is definition of complementary.
Okay.
Number 3, 1 is congruent to 3. Why?
Isn't that the given too?
Correct. And number 4 is the measurement. I mean, some of these seem a little ridiculous. It doesn't seem like you need this number 4. In other words, we've already said angle 1 is equal to angle 3. And what number 4 says is the measurement of angle 1 is equal to the measurement of angle 3. Well, why is that?
That the definition of congruent angles?
Yeah. In other words, if one angle is congruent to another, then that means that the measure of the one angle is the same as the measure of the other angle. Okay, number 5.
That would be the given too.
Okay, number 6.
Definition of congruent angles.
Yep. Number 7. Angle, the measurement of angle 3 plus the measurement of angle 2 is equal to 90 degrees. Why is that true?
Definition of complementary angles?
Substitution.
Oh.
In other words, notice that in statement 3 we said angle 1 was congruent to angle 3. Well, is all number 7 is doing is stating statement 2, only they're substituting angle 3 for angle 1. See that? In other words, statement 2 says angle 1 is plus angle 2 is 90 degrees. Statement says angle 3 plus angle 2 is 90 degrees. Well, and the reason they can say that is because in statement 3, they tell you that the angle 1 is congruent to angle 3. So therefore, statement 7 is true by substitution.
Okay.
And statement 8 is true by what?
Substitution.
Same thing, because they've told us that angle 4, measurement of angle 4 is the same as the measurement of angle 2. So you can substitute angle 4 for angle 2 wherever you see it. So the reason for 8 is substitution. And finally, number 9 says angle 3 and angle 4 are complementary because
would it be complementary angles, the definition?
definition of complementary angle. Oh, I see. I wasn't looking up here at the top. Yeah. So we could choose any of those 4, correct?
I think so.
Yeah, and that's what we did actually. And I like that a lot. That's what you want to do. In other words, I don't care the name of the theorem or even the title of the theorem. That does not mean anything to me at all. What's important is that you know these things. The definition of congruent angles, the definition of complementary angles, the substitution property of equality. And those 4 reasons were the only 4 reasons we had to use in 1 through 9.
Okay.
Okay? So that wasn't too bad. I like the way they're doing this. I haven't seen this before. More proofs. Does that mean your teacher is Miss Moore?
No, that's Zach. You just stole it from her.
Okay. Not sure who's worse, Hansack or Moore. And I'm not sure either one of them are bad necessarily, but are you taking honors geometry?
Mm-hmm.
Yeah, okay. All right, what else you got?
Do you want me to send you the next problem?
Yeah, that for stuff like this, it probably makes the most sense if you send me a picture. Merely because this would be very hard to verbalize. Algebra, not so hard. Algebra is pretty easy to verbalize. You can just read me an equation and we'd go about solving it. But geometry tends to be a little tough to verbalize. So in the future, you probably want to send me the stuff you want to work on before our session.
Okay.
That's the best way to do it. And then I have it, and I can even look at it ahead of time and see if I need to look at it ahead of time. So let me know when you sent it.
I just sent it. So, should get it soon.
Yeah, usually my phone will go off. It's odd, my phone gets it before my computer does. Yeah, my computer hasn't gotten it yet, but did it say sent?
No, it's still saying it's sending.
Okay, so it's still sending. Okay.
Yeah.
Yeah, I'm definitely not getting it until it says sent.
I don't know why it's taking so long.
There it is. See, my phone just went off. Actually, I got it this time first on my computer. Okay, let's have a look at this one. Okay, this is the second one, huh? And this one was right below the other one. So our reasons are still from those 4 choices?
I'm not really sure.
Probably. I'm guessing. In other words, this is the same page, correct? It's just below the other problem? Yeah. So the instructions for number 1 are probably going to be the same for number 2. So let's start out with statement 1. Why are they a linear pair?
Given.
Why are they supplementary?
Definition of supplementary.
Or definition of linear pair, right? Definition of linear pair. In other words, definition of supplementary merely means they add to 180. So we couldn't really use that as a reason for number 2. The reason for number 2 has to be because those angles are a linear pair. That's what makes them supplementary.
Okay.
Okay. Number 3.
Substitution.
Definition of supplementary.
Okay.
In other words, number 2, we said that they were supplementary, but that doesn't mean anything until we get to number 3, which says the measurement of angle 1 plus the measurement of 2 adds to 180. That's because they're supplementary. So the reason on number 3 is because definition of supplementary.
Okay.
Number 4.
Given.
Okay. Number 5.
I think this one is a substitution.
Correct. In other words, we're merely substituting 120 for the measurement of angle 2. So we're really saying statement 3, only we're substituting 120 for measurement of angle 2. Okay, number 6. Why is the measurement of angle 1 equal to 60?
Definition of supplementary.
I think we are using different reasons on this problem. And the reason for number 6 is subtraction.
Oh, yeah.
In other words, you can subtract any number you want from both sides of the equation. And what I'm doing is I'm subtracting 120 from the left side and the right side. And so I end up with the measurement of angle 1 equals 60 based on the subtraction theorem, or I'm not sure exactly what these are called. That would probably be the subtraction property of equalities.
Yes.
Okay. And then the measurement of 1 equals the measurement of 3.
The given.
Okay. And the measurement of 3 equals 60. Look at statement number 6.
Oh, subtraction.
Not subtraction. Statement number 6 says the measurement of 1 equals 60. Statement number 7 says 1 equals 3. So therefore, statement 8 says angle 3 equals 60 by substitution.
Yeah.
By substitution. In other words, is all I did was I substituted angle 3 for angle 1. Statement 8 is the same as statement 6, except I've substituted 3 for 1. And I can do that because I've already stated number 7. Okay. Now, angle 3 and angle 4 are a linear pair.
Given.
Angle 3 and angle 4 are supplementary.
Definition of linear pair.
Correct. And number 11, angle 3 plus angle 4 equals 180.
Definition of supplementary.
Correct. And number 12 is 60 plus angle 4 equals 180.
Substitution.
Correct. And finally, number 13 is the measurement of angle 4 equals 120.
A subtraction.
Correct. Correct. These aren't too bad. I like the way they're doing these. Yeah. The ones I hate is where you have to say angle 1 equals itself because of the transitive property.
Yeah.
Those are the ones that seem to me ridiculous. It even seems a little bit ridiculous to me that you have to go from statement 2 to statement 3. Well, no, that's okay. I understand that. Some of these always seem like they are really going out of their way to give you statements that need reasons. And that's why I think everybody hates proofs, if you want my opinion, is because of that. In other words, if I tell you that angle 1 equals 120 degrees, then it doesn't seem to me like I should have to add an additional statement that the measure of angle 1 equals 120 degrees. Those two statements to me say the same thing. But that's geometry, I guess. In other words, you have to kind of do it their way.
Do you want the next problem?
Yeah, if you got the other one, send it along. Let's do that one. I still kind of prefer the ones where they alternate and they give you some reasons and they give you some statements. And they give you at least one for each row. And you have to figure out what either the statement is or the reason. It seems to me that those teach the subject a little bit better.
We haven't really gone over all the statements, but...
Yeah, as opposed to giving you 13 statements and making you give them 13 reasons. Those weren't too bad, but I think it actually teaches two-column proofs a little bit better if you do it the other way. We'll see here what this one does here. Okay, this only has 5 on it. Number 1, what's the reason?
That's the given.
Number 2.
Definition of supplementary.
Correct. Number 3. I was trying to figure out why number 3 is true, and I finally looked and it was a given. So, okay. Number 4.
That be... I don't know.
That's the one that I hate. In other words, number 3 tells you the angle number 2 is congruent to the angle number 3. So why do we need statement number 4? Because all number 4 says is the measurement of angle 2 is equal to the measurement of angle 3. Well,
so is that the definition of congruency?
Yeah, I guess. I mean, I never have understood why they need statement 4. But this is where it starts to piss people off, is that you have to give a reason for statement 4. And it is because of the definition of congruency. You got it. So number 5.
That substitution?
Yeah. Yeah, is all I'm doing is I'm taking statement 2 and I'm substituting the measurement of angle 3 for the measurement of angle 2, and I've just stated that in statement 4, so I can do it. And so that's why you can state that, number 5. And that's what we were attempting to prove, was that the measurement of angle 1 plus the measurement of angle 3 is equal to 180. And if you look at their picture, that's not obvious. In other words, you would never really say that necessarily that 1 plus 3 is equal to 180. The only reason we can say that is because 2 is equal to 3. And we know that 1 and 2 are supplementary, therefore 1 and 3 have to be supplementary. And this is the way I actually prefer to talk about geometry, as opposed to the words congruent and as opposed to the word measurement of. If I was talking about this picture, I would say that 1 plus 3 is equal to 180. That's the way I would talk about it.
Okay.
I'm not saying that's correct, but that's what you'll do the rest of your life. You know, once you get through this chapter on proofs, you're never going to go back to saying the measurement of angle 1 plus the measurement of angle 3 is equal to 180. It's just too verbal. In other words, you don't need to do that. Everybody understands what you're saying if you say 1 plus 3 is equal to 180.
Okay.
Okay?
Okay. Do you want the last problem?
Might as well send it away. I do have a 5 o'clock, so I only have like 8 minutes. But let's see if we can have a look at it by then. What makes online tutoring so practical is the fact that you can send me 4 pages within a half an hour here. Okay. Must have got it.
This one switches off.
Ah, this is the one. This is the way I like it. This makes you think a little bit harder. Okay. So what's the reason for statement 1?
The given.
Okay. What's the statement for statement 2?
Angle 1 equals angle 3.
Angle 1 is congruent to angle 3.
Okay.
Okay. In other words, you need the congruent sign instead of the equal sign.
Okay.
And then what's the reason for statement 3?
Definition of congruency.
Correct. What's statement 4 going to be? Look at statement 5 and tell me what statement 4 probably is.
Angle 2 and angle 4 are vertical angles.
Correct. So statement 5 says angle 2 is congruent to angle 4. What's the reason for that?
Vertical angles are congruent.
Correct. And what's statement 6 going to be?
Measurement 2 equals measurement 4.
Correct. And number 7 gives you the statement and wants the reason. The statement is 1 and 2 are supplementary. Why is that?
That's the given.
Correct. Number 8. Why is the measurement of angle 1 plus the measurement of angle 2 equal to 180?
The definition of supplementary.
Correct. Number 9. We can see that the reason is the substitution property. Well, what are we substituting for?
Wouldn't we put in
What's the blank here got to be? If you look at the line above.
measurement 3?
Yes. Because of the substitution. In other words, statement 3 said the measurement of 1 is the same as the measurement of 3. So statement 9, instead of measurement of 1, I'm substituting measurement of 3.
Okay.
Okay. And now statement 10 says the measurement of 3 plus the measurement of 4 is 180. What's the
definition of supplementary?
That's substitution again.
Okay.
In other words, think of what 9 says. What 9 says is the measurement of 3 plus the measurement of 2 is equal to 180. Well, what I'm really doing is substituting angle 4 for angle 2 in statement 10. So statement 10 is substitution property. And finally, statement 11 is always what we're trying to prove. So we have to figure out what statement 11 is, just go up and figure out, it's got to be angle 3 and angle 4 are supplementary.
Okay.
And that's because of the definition of supplementary angles.
Okay.
All right, Allie. Well, I'm glad you got back to me and we had our session.
Thank you.
You're welcome. I will talk to you next week. And like I said, you might want to try to get these pictures to me a little bit in advance.
Okay.
Okay, and we're going to be on every Wednesday at 4.
Mm-hmm. Yeah. Okay.
Talk to you next Wednesday.
Bye. Thank you.
All right, bye-bye.